Hi students, welcome to physics classes. Today we'll discuss about refraction. In previous sessions, in the topic of light, we discussed about different types of mediums: transparent, translucent, and opaque. Transparent means materials which allows most of the light through them. Translucent means materials which allow partial amount of light through them. Opaque means which will not allow the light. And we discussed about opaque mediums. When light falls on the opaque medium, opaque surface, it bounces back into the same medium. When light falls on the opaque medium, opaque surface, it bounces back into the same medium. That is what reflection. Reflection is the second property of light. Reflection is the second property of light. What is the first property? Rectilinear propagation. Rectilinear propagation means light always travels in a straight path. That is rectilinear propagation. Second one is reflection. When light strikes any opaque surface, it bounces back into the same medium. That is called reflection. Now the third property, when light falls on the transparent medium, what will be happen? That we'll discuss in the topic refraction. It is the third property of light. This is the third property of light. We'll discuss detailedly about refraction of light in today's class. Now, refraction of light. When light falls on plane surfaces. Refraction of light at plane surfaces. Now, we'll discuss one activity. This is a vessel, empty vessel. We placed a coin at bottom of the vessel. Coin or black color stone, dark color stone, whatever it is, we placed at bottom of the vessel. Now here onwards we are seeing this is our limit. From here to here, wherever we are able to see that coin clearly. Beyond this, if we go, we can't see. Beyond this limit, if we go, we can't see. That is because light always travels in a straight path. So this is the minimum bending of the light. This is a maximum possibility we can see up to here. Maximum possibility that we can see up to here. Then if you come down, we can't see. Here also this is the maximum possibility. Then if you come, we can't see that object. Now we'll see here. If we are here, we are able to see that coin, this black coin. If we are here, we are able to see. Now this eye came still more away from the view, so he is unable to see that coin. If he wants to see, Straight. Light always chooses a path in a straight path. Like this he can see. So he can able to see up to here. This path he can see. That point he can see. But this coin here obstruction is there. So he can't see. Now if you pour water here. If you pour, for understanding I am using another color. Water here. Now, do you know when we place a lemon in the glass of water, it appears raised. We are regularly seeing that in the shops. Water glass, in that if you place lemon at bottom of the vessel, it appears somewhat raised. Why it is raised, why it appears like that, we will discuss. Now whenever the water is pouring in the vessel, initially without water, if you are seeing here from here, you are not able to see this coin. But after pouring water, you are able to see this coin. That means its position is here. Coin position is here. This is the position of the coin. Actually, this is the original coin. But because of water, it appears to be raised. So, if he is seeing, he can able to see that coin from this point. Without water, he can't see. With water, he is able to see at this point. But actually, coin is here? No. Here there is no coin. Coin is present at the bottom of the vessel. But he is seeing here in this view. That is why, because when the light in reflection we discussed, when we are when we are able to see the object, if light falls on that object and that light is reflecting from that object, that reflected light reaches to our eye, then we are able to see that object. Light should fall on that object and it should get reflected light should reach to our eyes, then only we can see that object. Now here there is no coin. Actually coin is here. The light falling on this coin is reflecting, and that reflected light should reach to our eyes. If there is no water, that reflected light ray follow this dotted line's path, not reaching to our eyes. But whenever there is a water, the light ray is bending at this point. Actually the coin is here. It is traveling like this. While traveling from water to air, it is changing its path, so that coin is appearing in this position. This is not actual position of the coin. This is the apparent position of the coin. This is the actual position of coin. When light ray traveling like this, after reflecting from the coin, it is bending at the interface. This is separation of air and water medium called interface. At that point, it is bending. Light ray is bending. That's why it is appearing here. Why light ray is bending here? Now we'll discuss why light ray is bending. Now we know speed of light is different for different mediums. Speed of light is different for different mediums. it is equal to 3 into 10 power 8 meter per seconds in vacuum. While coming to air, it is nearly equal to 2.9 into 10 power 8 meter per seconds. But we will take in air also nearly equal to 3 into 10 power 8 meter per seconds. Coming to water, its speed is still decreasing. Coming to glass, still it is decreasing. That is mean that we can say speed of light is different in different mediums. So when the light ray traveling from one transparent medium to another transparent medium, when light ray traveling from one transparent medium to another transparent medium, for example water to air, its speed is changing. Its speed is changing where at the interface the process of changing of speed of light at the interface, the process of change of speed of light at the interface, which results change of direction, is known as refraction of light. Refraction. Process of change of speed of light at interface, where speed of light is changing at the interface while it is traveling from one transparent medium to another transparent medium. While it is traveling from one transparent medium to another transparent medium, speed of light is changing. Because of the change in speed, light ray bending changes its direction. That is known as refraction of light. That is known as refraction of light. Now this bending is always possible. This changes direction. Direction is changing. Is always. No. Only except one condition. Except only in one condition it is not possible. Only in one condition it is not possible. Except this one condition, remaining all cases, except this one case, remaining all case, speed direction of light changes. What is this one case? We will discuss. Before we will discuss when it is changing. Then after we will discuss when it is not changing. Okay? Now we'll see when light ray traveling from one medium to second medium, medium 1 to medium 2. Now this is the interface. For example, we will take this medium 1 is air, medium 2 is water. Medium 1 is air, medium 2 is water. Now while traveling from air to water, speed of light is decreasing at the interface. Speed of light decreasing at the interface. That's why when light ray is coming like this in the air, while coming into the water, speed of light is decreasing at this point. Speed of light is decreasing at this point. Now I'll tell you one example. In a running race, 4 students are running. If they all are having equal speed, wherever you see, they will be in the same position. If all are having same speed. For example, if this particular student is having less speed, then who are having same speed will be in the same line. Less speed comes back. Whenever light is traveling from one medium to another medium, when its speed is decreased, it bends towards the normal. Just like an example, whenever speed decreased comes towards the normal. In the same case, four members are running with equal speed. Suddenly one member's speed is increased, then he will be forward. He will be forward. Like that, we can see another case. When light ray traveling from one medium to another medium. Now here we will take traveling from water to air. We know when light ray traveling from water to air, its speed will be increases. Now the light ray is coming like this. Whenever it is entering into the air from water to air, its speed will be increases. Like here, it will come away from the normal. Now I think it is very easy to remember. When speed is decreasing, coming towards the normal. When speed is increasing, moving away from the normal. Towards the normal, away from the normal. Towards the normal, away from the normal. Okay. Now instead of saying speed is increasing, speed is decreasing, we have mediums broadly classified into two types. Mediums classified into two types. We have examples for transparent medium: air, water, glass. Air has more speed, 3 into 10. In air, light speed is more, 3 into 10 power 8 meter per seconds. Water 2.25 into 10 power 8 meter per seconds. Glass 2 into 10 power 8 meter per seconds. Now mediums are classified into these three examples are classified into two types. One is rarer medium, another one is denser medium. Rarer medium, denser medium. Rarer medium in the sense, rarer medium, in which medium speed of light is more. Speed of light is more. That medium is optically rarer medium. Optically rarer medium. Completely we should say optically rarer medium. Optically denser medium, in which speed of light is less. That medium is optically denser medium. Speed of light is more, optically rarer. Speed of light is less, optically denser. Now, in air, speed of light is more. So air is a rarer medium. In glass, speed of light is less. When coming to compared to these three, air has more speed of light, rarer medium. Glass has less speed of light, denser medium. Then what about water? Water, when compared to air, water is a denser medium. I told, when compared to air, water is a denser medium. We can only compare two mediums at a time. If you take air and water, air is a rarer medium, water is a denser medium, because speed of light relatively more in air, less in water. So air is a rarer medium, water is a denser medium. Now coming to glass. When compared with glass, water is a rarer medium. When compared to glass, water has less speed. Water is a rarer medium. Glass is a denser medium. When compared these two, when we compare these two, water is a rarer medium, glass is a denser medium. Now, coming to previous condition. When light ray is traveling from air to water bending towards the normal, air is a rarer medium, water is a denser medium. When light ray traveling from rarer medium to denser medium, light ray bending towards the normal. When light travels rarer to denser, bends towards the normal, bends towards the normal. When light ray travel from denser to rarer, light ray travel from denser to rarer, it bends away from the normal, it bends away from the normal.